Welcome back to week 8, and in video 3 we are going to continue on and talk about some of the major types of folds and faults, and then I'll also mention how they form as well. So the major types of folds and faults are, there's a bunch. We've got for folds, anticlines, synclines, asymmetric folds, overturned folds, and recumbent folds. And then for faults we have normal, reverse, and strike slip. And here's just a couple images here showing you anticline, syncline, and then the two major types of faults, reverse fault and normal fault. So folds, here's a great picture of one of these folds in Montana. Here you can see the rocks are coming down and are curved right underneath, and then they have some debris on top. So this is an example of an anticline that is also asymmetric. So I'll get to why that is in these next few slides. So anticlines, when we look at the rocks in the subsurface, if we were to take a vertical slice into the earth, they would have an A shape. And here you can see this is going to be symmetrical because on either side of this axis, which is going to be the dotted line, that's going to be a mirror image on either side. And when we take those rocks that were bent into that A shape and we erode down into them and remove the surface layers, we're going to expose older rocks in the center, and then we'll have younger rocks on either side because the rocks on the bottom had to be there before the rocks on the top were deposited. So older on the bottom, younger on the top. In synclines, when we look at the cross-sectional view of those rocks, we're going to have a U shape in there. And then when we erode into that U shape, we're going to expose our younger rocks in the center and our older rocks on the outside. So if you're looking at a geologic map and you're trying to figure out, okay, what type of feature is this? Is this an anticline or a syncline? That's how you're going to be able to determine that. So our other types of folds, so if we took, these are all going to be anticlines just to kind of simplify things a little bit, and your book has some great images and diagrams regarding these formations as well. So an asymmetrical fold, if we took our A shape, we've got our axis here as a dotted white line. Our limbs, the sides of the fold on either side of this axis, are not mirror images of one another, so it's not going to be symmetric. Recumbent fold, the fold is actually bent over, and we see that it is kind of on top of itself a little bit. And then in overturned, we've got them totally squished. We have multiple folds that are one on top of another in the cross-sectional view. So just to give you an example of what some of these look like, an asymmetrical fold down here, you can see it's an anticline. Right here, comes around, we have a little tiny syncline and then another anticline. So this is going to be an asymmetrical fold because one side is not symmetrical to the other. And then here we've got a recumbent fold because it's kind of wrapped around, bent back over itself. So those are two of the major types of folds. And before I get into faults here, I just want to mention with these folds, and you'll see this in your book really, really nicely, is sometimes these rock units that have been folded, they're alternating layers. Now, alternating layers of different type of rock. Some that are really resistant to erosion, some that are not. And so when these rocks get eroded into, you might have ridge lines that develop as a result of those more resistant rock units. So if I go back up here to our types of folds here, for instance, in the syncline, this orange layer might be a lot more resistant to weathering than this tan layer. So these orange layers are going to form ridge lines on the surface of the earth. Same thing here. If this was going to be our more resistant layer, and then the tan also going to would be our less resistant, going to erode easier, we'd have a ridge line as well. So you'll notice that when you start to look at aerial photographs of these features. So faults. When we see breaks in the rock where there hasn't been any movement, we call those joints. Things like the columnar jointing we see in Oregon, in the columnar basalts that we have in the gorge. And these are some rectangular joints in Acadia National Park in Maine. So joints, fractures in the rock where there is no movement. But faults are where we have breaks in the rock where we actually have movement. So strike slip, this is where you have a fracture in the rock, but the rocks are moving horizontally past one another. We end up with stream channels that get diverted and have right angle bends in them. We can have roads that are offset. Rock units, like if we have a ridge line, that can be offset as well. Normal fault, we have a break in the rock unit, you can see here, and we see that one side of the fault is moving down in relation to the other side of the fault. So here we've got down, and then one side moving up. And with reverse, the movement's the opposite. One side is moving up over on top of the other. So one thing that you'll see in your book is one of these sides is referred to as the footwall, and one is referred to as the hanging wall. The footwall would be this side. If you were a little kid drawing a picture of a person, a lot of times, I know I did this when I was a kid, I would draw the feet of my people in this shape you can see here. So these would be your toes right here, and this would connect up to your leg. So this would be your footwall, where you have this kind of one side sticking out a little bit further on the bottom. And then the one that's kind of hanging on to that foot is going to be your hanging wall. So in your normal fault, your hanging wall is moving down, and in your reverse fault, your hanging wall is moving up. And then the last type of fault is what's called a thrust fault. And this is where you have a high angle reverse fault. So you have, or sorry, a low angle reverse fault. So you have a dip of 45 degrees or less. So almost really close to horizontal. We see these a lot where we have lots and lots of crustal deformation. Another feature that we get forming as a result of multiple normal faults are what are called Horst and grabens. And these should sound familiar to you because when we looked at arid environments, we had a series of these Horst and grabens in that environment. So what we end up having is when we have tension pulling on the crust, we have the crust starting to fracture and break apart. And we get these normal faults where parts are dropped down in the center and then parts are going to be lifted up. And so if we look here, oops. If we look here at our Horst and graben little mini video, you can see we pull on that crust and we see the grabens falling and the Horsts rising up. So those would be normal faults, where your hanging wall, this graben, is moving down in relation to your footwall, which would be those Horsts. So that's Horst and grabens. And then looking at faults on maps or aerial photographs, you might see a fracture in the Earth's surface. You might see what's called a scarp that is left behind from one side moving down and then where these people are moving up. And you might see offset rivers and whatnot. Cool. So hopefully you guys should be able to, after the next video I talk about how some of the major stresses that act on rock units, like compression, extension, and shearing, relate to each type of stress that is applied, and then the different structures that we get. So in the next video, we're going to get into that detail for you. So we'll see you later.